Are you there, David?
I think I am, and
fantastic.
I can hear you well.
Welcome. Thank you very much. Are you able to share your slides with us?
Yes, in a second.
Thank you.
Then I will ask you, please, thumbs up for me if you can see.
Yes, we can see you. We can hear you. We see your slides. Everything is good. Please take it away when you're ready.
Okay. First of all, thank you for inviting me. Greetings from the Amazon forest, where I am now. It's incredibly early here. I'm not sure if it's late at night or early in the morning, too early in the morning. So forgive me if I don't concatenate the scientific ideas here in the proper way. But anyway, I prepared a real quick presentation for you, just to give a glimpse of the excitement we are living here, with the prospect of starting soon what will be the first phase experiment ever in a tropical forest. So we didn't start yet, so I will show you some of just a hint, let's say, on the baseline discovery we have so far. We're having a long record for baseline measurements now, and also touch some of the modeling activities we are doing. Little bit of the context. On your right-hand side is a figure of the newly published IPCC report, the volume 1, published last year. I obviously like this figure because it shows the importance of the tropical land, both for the beta effect of elevated CO2, so the elevated CO2 effects only in plant ecophysiology and the implications of this for the on-plant, for the carbon cycle, and also for the climate, and also the importance of the tropical land when you get only the radiative effects of elevated CO2, which is the central panel there in the figure. But even when you combine the two effects, the beta effect and the gamma effect, we see the beta effect still dominates in our system models, such that we have an intake of carbon to land. So, and the tropical land is acting as the strongest sink of carbon to Earth's surface, at least in the continents. Another strong motivation for doing this phase experiment in the Amazon is that I copied here just the header of this recent paper showing that the Amazon dieback hypothesis is still alive, unfortunately. For us here living in the region, it's still a possibility. It's appearing in some of the CEMIP6 models, as this article is showing. And now I will move to the bigger graph there on the more left or central part. This is a graph from a commentary by Anya Hamik, which I suppose is in the audience there with you, commenting on a paper by the Rainfall community, comparing, this is observational data mostly, I mean, the data before 2010 or more or less up to 2010, 2015 there. Is observational data showing that both African and Amazonian forests has been acting as carbon sinks. But in the Amazon, it's the strength of this sink has been reduced by some 30% since the 90s, and should that trend be kept, we'll reach a zero balance sometime next decade, and after that, maybe turn into the Amazon forest could turn into a source of carbon to the atmosphere, which makes this experiment even more important because CO2 fertilization, the supposed CO2 fertilization effect plays a key role in that story. Okay, what's the status now? We didn't manage to get the money to do the experiment at the time we wanted, but there was a good side on that because we had a longer, what I call here, integrated baseline data from the phase plots. What you see in the background is a drawing, okay, it's an illustration, it's not a photograph. In the meantime, while we were waiting for the money to come, we implemented some open top chambers there. I will show you one quick result on that. And now we have last year in COP26 in Glasgow, we announced a generous funding from the UK government which is being now leveraged with funding from Brasilia here, from the Brazil government as well, to construct firstly 2 phase plots. We are already purchasing the towers and cranes for these 2 phase plots. They should be operational early next year. And after that, we'll move on to construct other 4 plots, which should be operational in 2 years from now. Of course, if I would talk to you about baseline data, I should talk about basic stuff to describe the ecosystem we have there, which is a tropical forest. You see a figure there on the estimated NPP from a few years of the baseline measurement, thanks to Rich Norby, again, because he's been working this data as well. But what I would like to highlight here is that the term integrated I used in the previous slide. We are doing this baseline measurements in such a integrated way that we were not supposed to do new science in this baseline period, but we are following all the processes together in a way that others didn't do before, such that we are finding new things for science in this forest. So I give you just one example here because of the time, but one thing is this supposed synchronicity of phenology above and below ground of fine roots and leaves there. But please don't misinterpret this graph, because the green lines there is litter fall and not leaf flushing, okay? So it's not that it's asynchronous. In fact, they are synchronous. The shedding of leaves and the reduction of the fine root stock in the soil across seasons there. And it gets reduced, especially during the dry season. And by the way, Belinda, the region here is also hit with climate extremes. We are currently hitting the record here of rainfall with the La Nina in the Pacific, which is disturbing a lot the construction plans here. It simply doesn't stop raining. So this is just a glimpse on some of the baseline philosophy we are following here. An eye on the open top chambers, you see a picture there of the design we did. They are implemented in the understory without, I mean, the major plants you see there, they were there before. So we just place the OTC there. We didn't plant these saplings there, but we could also, in parallel, conduct experiments in pots, as you see there, this brown small structures there inside the OTCs. But the central result you see in the slide there, it's relative to the native plants that were there before, and they are from many species, okay? So this is the average for all of them. We saw a difference, a short-term effect after 4 months of more than 30% increase in saturated photosynthesis. So you have to provide light to these understory plants because they live basically in the dark there. So when you provide light, you see a difference there of more than 30%. But we didn't see a significant difference in stomatal conductance, but I'm not showing here, but we saw an increase in leaf area. So if we integrated to the understory canopy, something we didn't do yet, the water flux would increase, which is tricky because there is a notion that the canopy exposed to the sun will show a decrease of stomatal conductance, and we raised the hypothesis that maybe the understory can compensate this somehow, but this will be checked only after a few years of the ecosystem scale CO2. Interestingly, in the OTCs, we also saw we are seeing, even though in a different time horizon now, this is a 12 months long monitoring of roots in the soil and in the litter. In the soil, we saw a reduction of root productivity, but an increase, very significant increase in root length. It seems like these roots are mining more phosphorus there, but they don't need to increase their biomass to do that. These are the very first results from this OTC experiment that's been running for nearly 2 years now. I would like also to touch briefly the modeling activities, and this is of course, our showcase so far from the Amazon Face experiment. Of course, you can navigate the different processes there, but I would like to focus here on the biomass because the world wants to know this variable, how this variable will change in the Amazon when we have more CO2, whether we're gonna have this CO2 fertilization effect influencing ultimately biomass there. And as you can see, if we constrain models with the nitrogen cycle and phosphorus cycle, the response gets on average reduced, but all the same as Belinda's exercise, she was showing the variation interval is still too large, which reflects our poor knowledge on the phosphorus cycle there. But we have a partner project, a partner experiment close by the Amazon Face experiment. There is adding nutrients to the soil. There is an article coming in Nature showing or proving for the first time what we kind of expected before, that these forests are phosphorus limited, just like they're in Australia. We are now, we will not abandon, what I will say now doesn't mean we will abandon regular DGVMs, but we are now also conducting a model intercomparison of trait-based models, because this is going to be not only the first phase in the tropics, but this is going to be the first phase in a highly diverse forest. We have in our 6 plots more than 400 different species. So it's for some it might be a nightmare, but others see it as an opportunity. So for the first time, we see the effects of CO2 on a highly diverse ecosystem or forest. at least. So finishing now, the outlook. I mean, one of our main hypotheses is that we might see an effect in the beginning, but this might be constrained by the phosphorus limitation with time, but there are counter hypotheses or alternative hypotheses that plants might develop mechanisms to acquire the phosphorus that are in these soils there, or at least some of the species there might be able to do that, and the ecosystem might change, which give us a hint that the ecosystem might change in the long term with elevated CO2. I also thank the whole team by showing some of their faces here. Thank you again for inviting me, and I'll be glad to, I'm looking forward for the discussion time now.
Great, thanks very much, David. That's a really fascinating set of talks and lots to look forward to in the future from the Amazon face getting on board as well. So we've got until 10:30 for questions, I believe. Yep, so we can kick off. Maybe we'll take one from online first. Oh, we've got one over here. Right, thanks, Suzanne.
Yeah, so one question from the online audience, Richard Nair. It's a question for David. So he's asking for the fine root biomass you show. Do you have an idea what is driving the peak fine root biomass in 2019? And do you expect this peak biomass to be variable between years as you go into running the Amazon phase? Is David there?
Maybe if anyone has a question for the others. Yeah. We'll come back to that question after this one if David reappears.
Yeah, thank you for the interesting results. I was interested in a question to you, Sami, about leaf area index changes in Bi4 phase. And did you also look at water fluxes and changes like in stomatal conductance, evapotranspiration, and these kind of things?
So the LAI measurements are currently underway. We don't see a very stark response yet, so I didn't show the data. There is some variability in responses, but not consistent in terms of LAI. And a student here is currently looking at the total water budget in terms of stomatal conductance in Saplos, Susan, right? But we see a bit of an increase in soil moistures in the top 12 centimeter under elevated CO2 that we otherwise predicted that there would be lower. The moisture would increase under elevated CO2, but on average, I think 7 to 8% it's gone down. So stomatal conductors have yet to come, but it looks like the higher root biomass in activity might be just pumping more water out, drying the system rather than what we thought initially would be moistening the system.
Okay, thank you.
So stomatal conductors have yet to come, but this is what I know so far in terms of the soil moisture dynamics in the top 12 centimeters using TDR probes.
Thanks. Let's go. We've got David back again now, so we'll go back to our online question. So, Susanna, if you could take that.
Yes. Yeah, so from the online questions, there's a question about the fine root biomass in 2019. So do you know, do you have an idea what's driving the peak fine root biomass in 2019? And do you expect this to be variable between the years when you go into the experiment? David.
I'm afraid I didn't hear the whole question. Sorry.